Start recording. Okay. Are you able to see my screen? Able to hear me? Everything is good.
Yes.
So today is I think session 9. I'm not sure.
Already, where did you go?
Uh, let's wait for her. Um, okay. Arun, is it fine now?
Yeah, can I just join from another device? Cause I don't
Yeah.
think
Yeah.
the
Sure.
internet will come now. It was like we're in a dorm, so that's probably the problem.
So are you joining from another device right now?
Yeah, 1 second, I am.
Yeah.
Oh yeah, hello. Can you hear me?
Yes. Okay. Now everything is good, Arun?
Oh yes.
So I believe we have today session 9 because like we had 4 weeks sessions completed. Today's
Yeah.
session 9 and the topic is recursion.
Yeah.
Before actually discussing about what is recursion, I hope ki you have a very little idea. You must be having some idea about recursion. So, so to actually
Yeah.
before going ki what is recursion, let's first understand why recursion is very important. Okay.
Mm-hmm. Yeah.
Okay. So the point is, according to me, recursion is like one of the most important topic because when we will be like discussing further topics in this course, so recursion
Mm-hmm.
will be used almost everywhere. For example, recursion is used when you will be solving backtracking problems. Have you heard about backtracking?
We have heard about it. Yeah. Not
I
sure
don't
what it
really
is.
know. Yeah,
Okay,
I
so
don't really know what it is.
backtracking means ki like in problems where we need to find or where we need to consider all the cases, all possible cases where we need to consider. For example, have you heard about a problem Sudoku solver? You are given a Sudoku. Have you solved a Sudoku before?
Yeah, like
Yeah,
in a book.
One
Yeah.
or few times. Few
good.
times.
तो बेसिकली सुडोकू में क्या होता है कि कुछ नंबर्स ऑलरेडी फिल होते हैं राइट एंड यू नीड टू फिल इन द
Yeah.
rest of the places empty places. So using backtracking also, backtracking is an algorithm paradigm using which you can solve these kind of problems. अब सुडोकू में क्या है कि बहुत सारा दिमाग लगाना होता है राइट यहाँ पे भी चेक करना है यहाँ पे भी चेक करना है लाइक इस लाइन में ऐसा करके
Mm-hmm.
तो बैक ट्रैकिंग क्या करता है कि बैक ट्रैकिंग विल ट्राई ऑल द पॉसिबल केसेस है ना बैक ट्रैकिंग विल ट्राई ऑल द पॉसिबल केसेस और जो भी केस like whatever case fits in this Sudoku, backtracking will
Uh-huh.
return that particular answer. So this is just
Okay.
one example of backtracking. There can be a lot of questions which can be solved by backtracking. Backtracking means trying out all possible ways, and that too efficiently,
Uh-huh.
not just brute force. Normal. This is not normal brute force. Okay.
Yeah.
So we will understand more when we will be talking about specifically backtracking in other sessions. So that's
Okay.
okay for now if you don't have any idea about backtracking.
Mm-hmm.
Then recursion will be used in divide and conquer. So divide and conquer is also a technique which we will be using a lot in future. Yeah.
Yeah.
Then recursion after divide and conquer we have like trees. So in
Okay.
any of the problems that we will be talking about of trees, let it be binary tree, binary search tree, right? Normal
Mm-hmm.
trees. जितने भी तुम्हें लीड कोड पे प्रॉब्लम दिखेंगे most of them, almost 90% of them will be solved by recursion. ठीक है?
Okay.
Does binary heaps come in inside of trees?
Yes. Heaps are
Okay.
also trees internally.
Yeah.
They will,
Yeah.
when we will be discussing about heaps algorithm, for example, uh, like insertion in heap, deletion from heap, and
Yeah.
or heapify. So all of these functions, or you can say methods, we will be using recursion.
Okay, because we just started learning heaps from last class, so I was just wondering what it was under.
Yeah, you must have like learned this. Ki heaps are internally trees, right?
Yeah, they're complete full binary like that, something.
Complete
He didn't
for?
go over it much. He went over it for like 10 minutes.
So do you know what is complete binary tree? What is full binary tree? Do you know about this?
Yeah, somewhat, some idea he gave.
Okay, cool.
And yeah.
Then we will be discussing about graphs, right? So in
yeah,
graphs also, we will be discussing about a lot of traversals. In trees also, we will be discussing about a lot of traversals. For example, like most famous, which is DFS. Have you heard about depth first search before?
no.
No, cool. I expected this, don't worry. So
Is
in
it the
graphs,
depth of a tree? Is that the
no. It's a
No,
searching
no.
technique, actually.
Okay.
So we will be discussing all of this in future, don't worry. So similarly in graphs also, a lot of algorithms are based on DFS, and this DFS is based on recursion. Why a lot of
Okay.
noise coming from your end?
We have roommates, so
Oh, okay, understandable.
yeah.
Cool, no worries. And then one of the most important topic, which is like dynamic programming. Have you heard about this?
Yes, we just heard of it. Like our professor keep talking about these terms.
Okay, he never
Literally.
really explains this, just talks about it.
No, no, he's like, oh, you're gonna use dynamic programming in the
He's
future for
like,
interviews and everything. He's
Okay.
like, it's like some optimization, like using recursion and stuff.
Correct, correct, correct. So in dynamic programming, you can say it is like sort of recursion plus memoization. So we will see like why we need a memoization thing. But the point I'm trying to make here is we will be using recursion here as well. Okay. And then like
okay,
there can be a lot of things like as you mentioned heaps. So heaps can be here, like we can put heaps here. Okay. Then we can have segment trees. Now I don't think so you have heard about that.
No.
Segment trees.
no.
So this is actually a advanced data structure, and I don't think so we will be covering this in this course. If you are interested, I can cover it, but that's not really needed in terms of interview perspective. This is for like people who want to reach above candidate master and like code forces. Okay, so
Okay,
like who want
yeah.
to actually like focus on competitive programming rather than like interview preparation. These topics are for those people. But still, like if you
Okay,
want, if you are interested, we can cover it. So this is
okay,
also, as the name says, it's a tree. It's actually a binary tree, so it will be also using internally recursion. ठीक है? तो मैंने इतना सब क्यों बताया? Just to tell you the importance of recursion. Why recursion is
okay.
important? Because ये सारे future topics हैं. ये 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 ये
Mm-hmm.
ये. तो अगर recursion clear नहीं है ना, तो फिर इन सब topics में हमें कुछ समझ नहीं आने वाला.
Correct.
Cool?
Yes.
Okay. Let's understand what is recursion. Yeah. So now I want you guys to tell me what is recursion. What do you think recursion is?
So I feel, yeah.
Yeah,
Um,
please.
I at least I feel like it's more of like so far what I've learned, it's just like either you write a function or like any kind of code or any algorithm that you're writing, and like you use the same thing. You make a name of it and you use that name like a lot of times if you want to use it in some other code, so that you don't have to write like that same code again and again.
Mm,
Something like that.
no, I mean what you just said is कि you create a function and then you use it a lot of times.
Yeah. So what I think is that it's using a function and it calls that function one like more than one time. Yeah.
Okay, so let's say ठीक है.
Until like a specific condition is there.
Wait. So let's create a function, right? And it prints something. Okay. Now let's say if I'm calling this function like a lot of times.
Uh-huh.
So like what will be the output?
Just that like four times. Hello
Correct.
four
Hello will be
times.
4 times, right? Correct. Now is it
Mm-hmm.
recursion?
I don't um I don't think so.
Okay, you
I
don't
think
think?
it might be like using the function name inside of the function.
Oh, we got
Yeah.
some new definition. Good. What is the new
It's
thing?
just he
It's
mentioned
like
that in class one time. It's also what I did in the interview, like for Fibonacci. Like I did like so it was in Fibonacci and then I did Fibonacci inside of it. Like I returned Fibonacci. Like it was int fib and then I returned fib of n minus one plus fib of n minus two.
Okay, so we
So it's
got
like calling
some.
the function inside the function itself. So recursively calling it,
Oh, okay.
I think. I don't know.
So let's say we have a function one, hello one.
Yeah.
Let's say if I'm calling this function one inside this and this. So now what will be the output? First tell me.
So you're doing hello one from one. So it will keep printing hello until you have a specific condition that when you tell it to stop, I think.
No,
That's
like I mean what will
I
be the
mean
output for this code?
with first will
Take your time. It's not like you should not be in hurry. Take your time. अच्छे से देखोगे क्या होगा? Line by line क्या होगा?
you're calling fun. So I mean first it will print hello because you're calling fun.
Good.
And then it will call fun one, which then will print hello one.
Hmm.
That's it.
That's it?
Yeah, because in the fun function,
Hmm.
you just have that it's printing hello and it's calling fun one. So
Okay.
if you finish printing hello and then you finish calling a fun one by printing hello one.
Hmm.
So it will print
So,
hello one time and then hello one time. Yeah,
okay,
that's
let's
what
see.
I'm thinking, yeah.
Correct. You are correct. So is this recursion?
No.
But you told me, right? कि calling a function inside another function
No,
something.
no, calling the function
calling the
itself,
same
like the same
function.
one.
No. Yeah.
Oh. Oh,
Like you
okay.
know how I said like you have int fib, you call that same function like inside, like you return fib, like the same
Yeah.
thing.
Okay. So this is
Like if you look at
actually.
the
Yeah, yeah.
like the Fibonacci function, like the recursion, if you write that, then you have to use like the fib function again inside, like return Fibonacci of n minus one plus n minus two. It's like the usual function.
Correct. So now let me tell you first the definition of recursion. So you are actually correct. Recursion is कि when a function call itself. When a function
Yeah.
calls itself. Okay?
Okay.
Itself is very important.
Okay.
This is what we call recursion.
Uh-huh.
For example, so you were discussing about Fibonacci, right? So let's discuss
Uh-huh.
Fibonacci only. Okay, to take
Okay.
example of recursion. तो
Mm-hmm.
फिबोनाची क्या होता है बेसिकली लाइक हमें पता है कि फिबोनाची ऑफ n इज नथिंग बट फिबोनाची ऑफ n minus 1 plus Fibonacci of n minus 2, correct?
Right.
Yeah. Yeah.
So the point is if you see very closely है ना ये एक रिलेशन है राइट ये एक रिलेशन है
Yeah.
relation means कि like to get the nth term it depends on some of the previous terms, right?
Yeah.
So the point is कि to calculate Fibonacci of n we need the info of Fibonacci of n minus 1 and Fibonacci of n minus 2, correct?
Yeah, we do. Yeah.
Okay. So let's say now I want to implement Fibonacci number function. Okay.
Okay.
So I will be
Yeah.
taking an input from the user
Mm-hmm.
and I will say, okay, print what
Yeah.
is Fibonacci of n. Okay.
Okay. Yeah.
Now, okay, cool. So now what will be the Fibonacci function? So what should be the return type of Fibonacci number? The function?
It should be just an integer.
Correct, because we are printing here, right? We are printing here
Yeah.
this thing, so we should return something. So the printing,
Yeah.
the return type will be integer, and then we will say, okay, int n. So what its job is, what this Fibonacci of n's job is, its job is to return nth Fibonacci number, correct?
Yeah.
Okay. And
Yeah.
how do we find nth Fibonacci number? We can find it from here.
using the
So we will say, okay, return Fibonacci of n minus 1 plus Fibonacci of n
and one
minus 2. That's it.
Yeah. Yeah.
So who told this in interview, Arohi
there's
or Arohi?
also like base cases that we have to take care of, right? That's
Correct,
what I did. I mean,
correct. So what will be the
So
base?
basically, that's why
0 and
it's like if
1.
n is 0, 0, and then if n is 1, you return 1.
So if n
Yeah.
is less than equal to 1, can we say return n?
Um. Well, if it's 0, you have to return.
Yeah, you can do that. Yeah, that works too.
Yeah. Okay.
So will it work?
But what if it's 0? Then you just have to return 0, right?
So we will be returning 0, no?
No,
Oh
the if
yeah. Oh
statement
yeah.
will
Yeah.
work
Yeah.
as well.
It
I
will. It
just
will.
thought
It
of
will.
the original way we were taught.
If n is 0, what will happen?
It will return 0, and if it's 1, it will return 1.
So that's what we want, right?
Yeah. You're right. You're right.
Yeah.
Okay. So Fibonacci series अगर if we write, तो Fibonacci series क्या होती है? Like 0, then 1, 1, 2, 3,
1,
5,
1, 2,
8
3,
ऐसे करके,
5,
right?
8, 13. Yeah.
So this is
Mm-hmm.
0th guy, or you can say this is actually 0th guy, first guy, second, third, fourth, fifth, sixth
Mm-hmm.
guy, right?
Correct.
So
Yeah,
let's
that's what
check.
you wrote down.
If we write 5, we are getting 5, cool. If we write 6, we should get 8, cool. If we write
Mm-hmm.
0, we should get 0. If we write minus 1, what will happen? We are getting minus
Yeah.
1. Why?
Because
It's
less
because
than
if
1,
minus
so
was
they
less
just
than
have the
1,
same
so it
thing.
returns the same thing.
Yeah, so what should we do in that case if minus 1 is here? Like, let's say if you want to fix it. If a user provides negative number, you should print, ki, hey, the input is invalid.
So if n is less than 0,
Mhm.
you can just say input is not valid. Please
Where
input
should
n
we write
again.
this condition?
Right here in like the main, so you have CIN is greater than n.
Wait,
So that
tell me
right
the
after
line
that.
number. Tell me the line number.
22 after 21.
Good. If n is less
Yeah,
than
done.
0, then you just
You
need to
just
print
print,
invalid
ask
input.
them, yeah, and then ask them, yeah.
Else, you should do this. Correct?
Yeah.
Good. So that's actually a form, or actually an example of recursive function, because if you see closely, this function, when we define this function, it is actually calling itself. Although for different inputs, but it is calling it itself, right? That's important thing. So
Yeah.
if a function calls itself, this concept is called recursion. Okay. Cool.
Okay.
Okay. Now let's deep dive into it. So now, so we have discussed a Fibonacci like
Also,
function. Yeah. Yeah.
are we gonna get to like the time complexity of like the specific recursion Fibonacci? Because I didn't get that right in the interview because I wasn't sure like how to the time complexity of recursion functions.
Yeah, obviously we
So
will. I
he
will cover
explained me like
everything. No.
yeah, he
Please
explained me
don't.
like recursion. Yeah.
Yeah, I'll tell everything. Don't worry.
Okay. I was just wondering like about time complexity.
Yeah, I'll cover everything. I know that the time complexity of this is tricky. That's why I told you, okay, there is no need to solve it using recursion. We can do it iteratively. But still, like,
Yeah.
but still, like, we can see.
Okay.
Okay. So now, cool. So this Fibonacci is still like complex. Let's first discuss about the very basic function, recursive function, which is like calculating factorial of a number.
Yeah.
So now let's say the problem statement is given n, calculate n factorial. Okay. So tell me one thing, can we like solve it using recursion?
Yeah.
So for that we need to find out what is factorial of n, right? Factorial of n क्या होता है?
Yeah.
It is n into n
N
minus
times
1
n minus
times
1.
n minus 2 up to 1, right?
Plus 2, yeah.
Yeah. Yeah.
Can we say कि factorial of n is nothing but n times this thing, right? And
Yeah.
this whole
Yeah.
thing is nothing but n minus 1 factorial. Can we say this?
n minus
N times.
yeah, you can say
Yeah.
that's n minus 1 factorial.
Correct.
Yeah.
So we can say this is nothing but. The point is, we got this relation. The factorial of n is nothing but n times n factorial of n minus 1. Got it?
Right.
Yeah.
अब जैसे ही तुम्हें ये relation मिल गया ना, so you got the point that this function is recursive in nature. Why? Because to calculate factorial of n, it is calling factorial again inside it. And this is what we call relation, but in terms मतलब थोड़ा अच्छे से इसको हम recurrence relation बोलते हैं.
हाँ.
Recurrence relation is like the relationship between the functions, the dependency between the
Yeah.
functions.
Yeah.
ठीक है.
Mhm.
So the point is कि factorial हमें पता है कि to calculate factorial of n, we should calculate factorial of n minus 1. So now can we write the
Yeah.
code for factorial? Can we write the recursive function?
Yeah. Yeah.
Okay. So the same thing, given n, calculate fact of n,
Mhm.
right? So int fact int n. Now what should we write?
We should get the edge cases. So if n is 0 or if n is 1.
Yeah, that's what we call base case. I will cover base case in detail, but for the time being, just
Oh, okay.
consider.
Sorry.
No, it's
Yeah.
okay. It's okay. We
So-
have to write base case here,
So return n times
Factorial of n minus 1. Yeah.
right?
Yeah.
Now we should also
Yeah.
write what? Base case. अच्छा अगर base
Yes.
case नहीं लिखेंगे तो क्या होगा? Like what will happen if we don't write base case?
Then it will just return what we have. So it will be, if it's 0, then it will just be, oh wait, you can't do that. I don't really know.
If n is 0, then 0
So-
times negative 1.
For that we should
Oh, wait.
see into the internal working of recursion. ठीक है?
Okay.
तब जाके थोड़ा पता
Okay.
चलेगा क्या होता है base.
Mhm.
Take the same example of factorial. ठीक है? Let's say कि अगर हमने सिर्फ इतना लिख के छोड़ दिया, ठीक है? Let's say if we run this, let's see what happens. If we provide some input, let's say like 3, it is saying segmentation fault.
Oh, okay.
Oh,
Any
Oh,
idea?
I didn't know.
Any idea why it happened?
Wait,
Why base case is so
And-
important?
wait, but 3 is not. But why do we need base? Oh,
Hmm.
3 times. But 3 should work, right? Because that's not 1 or 0. So,
Okay.
yeah, that's what I was thinking. It should work for any other number that's greater than 1 at least.
yeah.
Oh, so let's try like 4. It should get the
No,
same.
3 is greater than 1, so I don't know why it's not working. for
Yeah,
3.
exactly. That's what I'm saying. Why it should work for 3.
Hmm.
So if we do put in a base case, if n is greater than.
Okay, wait. So let's first discuss internal working of recursion. ठीक है? Then we will like
Okay.
understand कि why we need a base case. Why a base case is very important. देखो अब internal working मतलब recursion अंदर से काम कैसे करता है, right? How recursion actually works. हमने तो पहले कोड लिख दिया था, right? Fibonacci का, but how it is actually calculating something, or how it will calculate this factorial. ठीक है? Let's see. For example, अगर the user provides 5, n is equal to 5. ठीक है?
Mhm.
अब सबसे पहले इस चीज से भी पहले हमें ये समझना होगा कि ये फंक्शन कॉल्स जो होते हैं ना, लाइक व्हेन यू एग्जीक्यूट योर कोड, इट गेट्स मेमोरी इन रैम. डू यू नो दिस? So let's say if this is your code.
It gets stored in memory.
No, wait.
Yeah.
It is your code, right? You have written a code, saved it. That's it. It is currently in your you can say it is currently present in your SSD.
Yeah.
Now when you execute this code, when you do like g++ something and then you do dot slash a dot out, right? Something like that. When you
Yeah.
run this code will become a process. You can say right now it is a program, which is just simple your code, which is present in hard drive or like solid state drive. So this is like a program. and then it becomes a process. You will understand these things in your operating system course, but for the time being, that's like a very basic introduction. ये process बन जाता है, and now it is in RAM. ठीक है? And then the CPU will actually like operate on it. So the CPU will like do the specific work, whatever you have written. ठीक है? So the point is कि जो RAM में इसको memory मिलती है ना, ये RAM में memory जो है कई sections में होती है. So for example, if it is your RAM, इसमें जो किसी भी पर्टिकुलर प्रोग्राम को मेमोरी मिलती है वो कुछ सेक्शंस में होती है. लाइक कुछ अलग अलग चीज, अलग अलग टाइप के मेमोरीज मिलते हैं. फॉर एग्जांपल, द फर्स्ट मेमोरी इट गेट्स इज हीप, द सेकंड मेमोरी इट गेट्स इज स्टैक, द थर्ड मेमोरी अ प्रोग्राम गेट्स is like for global. No, it's not queue. They are not data structures, they are different. Wait, let me explain.
Oh, okay.
So for global or static variables, and the fourth thing is for text for your code.
Oh.
The point is, whenever you run your program, it gets memory in RAM. अब RAM में भी मतलब like ये चीजें store होती हैं, right? Whatever variables you are creating, right? Whatever functions you are calling, ये सारी चीजें track रखी जाती हैं. ये सारी चीजें stored रहती हैं कहीं ना कहीं, right? Obviously they should be stored somewhere, right? तो ये तुम्हारा heap section of memory. It is not related with your heap data structure, ठीक है? This is heap memory, not a data structure. Heap.
Okay. Yeah.
There is also stack memory. Although this is related with your stack data structure because it works like a stack, that's why it is called stack memory. ठीक है? एक stack memory का section होता है. Similarly, तुम global variables बनाते हो, right? Global variables means जो तुम main function के ऊपर बनाते हो, यहाँ पे. इन variables को भी अलग से memory मिलती है जो कि यहाँ पे इस section में मिलती है, global section में. और जो भी तुम्हारा text है, whatever like text you have in your program, वो यहाँ पे जाके store होता है. So the point is कि जो function calls होते हैं या फिर जो तुम normal local variables बनाते हो, उनको जगह यहाँ पे मिलती है. They get memory allocated in stack. ठीक है? थोड़ा थोड़ा आ रहा है समझ में अभी?
हाँ.
Basically all function calls or slash local variables gets memory in stack. अभी आएगा धीरे धीरे समझ में. Wait. अब देखो क्या होता है एक्चुअली जब तुम किसी फंक्शन को लाइक किसी चीज को बनाते हो, किसी फंक्शन को कॉल करते हो. ठीक है? फॉर एग्जांपल, लेट्स राइट ओनली अ नॉर्मल फंक्शन राइट नाउ. ठीक है? एक नॉर्मल फंक्शन राइट करते हैं अभी तो. लेट्स फॉरगेट अबाउट दिस राइट नाउ. ठीक है? फैक्ट. अभी एक नॉर्मल फंक्शन है, लेट्स से हमारे पास ऐसे ही बस फंक्शन, और इसका काम है लाइक प्रिंटिंग समथिंग. ठीक है? और तुमने मेन फंक्शन बनाया और लाइक इसको कॉल कर किया. तो अब देखो जैसे तुम्हारा कोड लाइक लेट्स से दिस इज योर स्टैक सेक्शन ऑफ मेमोरी. ठीक है? स्टैक सेक्शन ऑफ योर मेमोरी. दिस इज मेमोरी. ठीक है? नॉट अ डेटा स्ट्रक्चर, ऑल्दो इट इज अ डेटा स्ट्रक्चर इंटरनली, बट इसका ये मेमोरी अभी हम डिस्कस कर रहे हैं. ठीक है? तो जैसे ही तुम्हारा प्रोग्राम रन होगा, सबसे पहला फंक्शन कौन सा कॉल होता है? Whenever you run any program, what is the first function that is like called?
The main one.
Correct, the main function. The main function will get memory inside this because main is executing right now. ठीक है? जैसे इसने ये लाइन पढ़ी, जैसे like we will start from line number 19. The main function will get memory in the stack. Now let's say if you create some local variables here, let's say int n, string s, all these variables n, s will get memory here. N is here, let's say s is here. आ रहा है समझ में थोड़ा थोड़ा?
हाँ. Yeah, a little bit, yeah.
Okay. Now this main function is calling the function func inside it. It means the main function will say कि hey, I depend on this function for my complete execution. I cannot execute without like calling this function func. So the point is this main function will say, hey, please call function func. So now this function will get memory inside stack because right now this function is now executed. So this is what we call recursion call frame, or you can say recursion stack, or like function stack, not recursion stack. Sorry. what we call function call stack. जैसे जैसे फंक्शन एक दूसरे को कॉल करते हैं वो स्टैक में मेमोरी लेते जाते हैं व्हेन दे आर एग्जीक्यूटिंग, एंड देन ये स्टैक की मेमोरी का एडवांटेज क्या है कि व्हेनेवर अ फंक्शन कंप्लीटेड इट्स एग्जीक्यूशन इट विल बी लाइक रिमूव्ड फ्रॉम द मेमोरी. ठीक है, तो फॉर एग्जांपल अब ये फंक क्या करेगा, इट विल से ओके सी आउट हेलो, तो ये प्रिंट कर देगा सी आउट एंड इट विल से माय फंक्शन एग्जीक्यूशन इज ओवर, सो नाउ यू कैन थ्रो
हाँ
मी. तो यहाँ से मतलब हम इसको हटा देंगे, ओके योर एग्जीक्यूशन इज ओवर, लाइक नाउ गेट आउट. So now still main is executing because function को इसने call कर दिया, it got output and now main is also
Yeah.
completed, तो main भी this call frame से हट जाएगा. And that's how like this memory works. So that's how memory allocation works or function call stack. ठीक है?
हाँ
Okay, cool. So now let's talk about the recursive function. अब थोड़ा समझ में आएगा कि why base case condition is important. ठीक है? So let's say कि हमने कॉल किया see out fact of 5.
हाँ
ठीक है, तो क्या आना चाहिए था, like we are getting segmentation fault right now but we should get like 120, right? Factorial 5 is 120.
right.
Now let's try to understand what is actually happening. ठीक है, इस केस में तो बताओ क्या होगा सबसे पहले, like फंक्शन कॉल कैसे काम करेगा, फंक्शन कॉल्स कैसे होंगे.
So for
सबसे पहले कौन सा फंक्शन आएगा,
main one
main.
5
So main function सबसे पहले main function will get memory.
main
Then main function depends on factorial 5 and main will call
factorial
factorial 5.
5.
Main will say,
Yeah.
hey, please call factorial of 5. Calling factorial 5 means
हाँ
factorial 5 will get memory, right? Now
right
factorial 5 is like above this main. तो इसका ये मतलब है देखो कि जब factorial 5 complete नहीं हो सकता, main अभी रुका हुआ है, main को memory से तुम you cannot remove main from the memory because stack, that's how stack works. अगर let's say ये stack
right
है तो अगर यहाँ पे कोई एलिमेंट है और यहाँ पे कोई एलिमेंट है तो you first have to remove this particular guy before removing this.
right
Obviously this is good, this is actually we want, right, कि factorial 5 का execution
right
खत्म नहीं होता जब तक main का खत्म नहीं हो सकता, right?
right yeah yeah
So that's why we first have to execute factorial 5. Now let's see what factorial 5 wants. So factorial 5 क्या बोलेगा, let's say कि factorial 5 है तो ये क्या बोलेगा, return 5 which is n. देखो यहाँ पे n is 5, right?
yeah
We will say return 5 into fact of 4, isn't it?
yes
So now factorial 5 will say, hey, I am dependent on factorial 4, so you have to calculate factorial 4 for me, right?
right
So now
yeah
factorial 4 will get memory inside your function called stack or your stack memory. समझ आ रही है बात?
हाँ
Yeah,
I understand
ठीक है, अब फैक्टोरियल 4 क्या बोलेगा, अब फैक्टोरियल 4 भी सेम फंक्शन यूज करेगा बिकॉज फंक्शन डेफिनेशन तो ये लोग सेम ही करेंगे यूज, राइट? तो अब फैक्टोरियल 4 क्या बोलेगा, फैक्टोरियल 4 विल
go
से
back to
रिटर्न 4
go back
into factorial of 3.
3
So now factorial 4 will say, hey, you have to call factorial 3 for me, otherwise I cannot execute, right?
right
So we
yeah
will get factorial 3 in memory. Similarly factorial 3 बोलेगा मेरे को factorial of 2 चाहिए, right?
हाँ
And fact 2 बोलेगा मेरे को 1 चाहिए, fact 1 बोलेगा मेरे को 0 चाहिए, and fact 0 बोलेगा मेरे को -1 चाहिए, और ये प्रोसेस इनफाइनाइट चलती रहेगी,
right
it won't stop. And that's what we call infinite recursion, or you can say stack overflow. Have you heard about the website Stack Overflow?
Oh, yeah, many
This
times
is the
actually.
concept.
Oh,
See, when you don't write a base condition to your recursive function, it will go on infinitely because it doesn't know, right, where to stop.
yeah
And that's how like
correct.
your recursion stack will like overflow, right? वो भर जाएगा पूरा. And that's why you are getting segmentation fault.
mm-hmm.
So the base condition will help your recursive function to stop when it is needed. So when should we
Yeah,
stop in factorial function? We should stop like when we know the output, right? For example, like base case क्या होता है basically? base case means the smallest valid input, right? Or you can say the largest invalid input. So it's इतना मतलब confuse नहीं करते हैं. Let's call it smallest valid input, whose answer you know already. For example, we know, right, कि factorial of 1 क्या होगा? 1 होगा. There is no
Yeah.
point of calculating it, right? There is no point of calling further recursion calls. So that's why we
Correct.
will say
There's none.
this is the base case. This is the smallest valid input that you have. This will be your base case. तो अब हम यहाँ पे base
हाँ.
case write करेंगे. Base case क्या बोलेंगे कि if n becomes 1, there is no need to call any other function calls. You just directly return 1. सही बात समझ में?
Right.
तो देखो अभी क्या होगा. तो ऑब्वियसली ये दोनों कॉल्स तो नहीं होंगे. जब हमारा n लाइक 1 हुआ, हमने फैक्ट 1 कॉल किया, फैक्ट 1 क्या बोलेगा? इफ n is 1, this condition will hit and it will return 1. अब ये return 1 किसको करेगा? It will return 1 to its parent function. और इसका parent function कौन है? The one who called it. तो ये इसको return कर देगा 1. ये फैक्ट 2 क्या बोल रहा था? फैक्ट 2 बोल रहा था यार कि I need this result 2 into fact 1, right? तो फैक्ट 1 क्या बोलेगा कि like please return 1 in place of me. तो यहाँ पे फैक्ट 1 की जगह आ जाएगा 1. And now you can actually execute और ये it will be gone from the memory. ठीक है, तो ये चला गया मेमोरी से. फैक्ट 1 एग्जीक्यूट हो गया पूरा, उसने रिटर्न कर दिया अपना रिजल्ट. इट विल बी लाइक वैनिश फ्रॉम द मेमोरी. ठीक है, यू विल लाइक वो फंक्शन निकल जाएगा मेमोरी से बिकॉज इट्स फंक्शनैलिटी इज ओवर. नाउ फैक्ट 2 को अपना रिजल्ट मिल गया, राइट?
Yeah.
फैक्ट 2 को मिल गया अपना रिजल्ट विच इज 2 into 1. तो फैक्ट 2 क्या बोलेगा? रिटर्न दिस 2 टू माय पेरेंट फंक्शन विच इज 3, है ना? बिकॉज फैक्ट 3 नहीं तो फैक्ट 2 को कॉल किया था ना. जब तुमने फैक्ट 3 लिख रहे थे तो तुम्हें क्या चाहिए था? 3 into फैक्ट 2. और फैक्ट 2 तुम्हें मिल गया विच इज 2. फैक्ट 2 ने बोला कि रिटर्न द रिजल्ट हियर. तो नाउ यू कैन कैलकुलेट फैक्ट 3 एज वेल, राइट? तो फैक्ट 2 भी अब मेमोरी से उड़ जाएगा. फैक्ट 2 विल बी गॉन फ्रॉम द मेमोरी. एंड नाउ यू कैन कैलकुलेट फैक्ट 3. फैक्ट 3 क्या होगा? 3 into like 2 which is 6. देन सिमिलरली 6 तुम यहाँ पास करोगे, फिर 6 into 4 24 यहाँ पास करोगे, फिर 24 into 5 तुम मेन को पास करो विच इज 120.
Yep.
सही बात समझ में? नाउ इफ वी रन दिस वी आर गेटिंग 120.
Yeah.
Oh, yeah.
So that's why base condition is important. So base condition is important to avoid stack overflow. Or you can say infinite recursion call. ठीक है? So if you are writing a recursive function, make sure to write base condition. ठीक है? If you don't write a base condition, it will like go on calling itself. Got the point? Got the importance of base condition?
Yeah. No, I got it.
Okay. And also like did you get the internal working of recursion? How like function calls happens inside memory?
Yeah. It makes more sense now. Yeah.
Okay. So eventually like धीरे धीरे फिर जब इसका functionality over हो गया, it will be gone from the memory. Then whoever is at top of this function call stack, it means we are executing that particular function right now. आई बात समझ में? If its execution is over, it will be like gone from the memory. It will be removed from the memory by somebody. Now who is that somebody? It doesn't matter to us right now. But somebody is here who will be like putting these functions into the stack and will be removing these functions whenever their execution is over. Got it? Hello?
Yes.
Yeah.
Yeah. Yeah.
Similarly, fact 5 will say, hey, I have calculated my result. I'm returning my result to main. And similarly, main will say, okay, I have printed that particular result. My function is also over. Like you can actually remove it from the stack. So when we remove main from the stack, it means your function execution is, sorry, it means your program execution is over. Okay? Because main is the first function which you put inside the stack. And if you're removing that particular main function from the stack, it means the main's functionality is over. It means your program's functionality is over, right? Your program is nothing but the main function. Whatever you write in main function, that only happens, right? So that's the point. That's how like function calls happen. Okay?
Yep.
Cool. So this is what internal working of recursion. तो function calls ऐसे होते हैं. अब अगर तुम्हें function call करने आते हैं तो तुम फिर recursion भी तो function calls ही करता है ना. ऑब्वियसली लाइक एक रिकर्शन फंक्शन कई सारे कॉल्स करेगा, ये तो हम मानते हैं, बिकॉज अभी तुमने देखा इस एग्जांपल में भी कि फैक्ट के कितने सारे लाइक इंस्टेंसेस आ गए थे हमारे पास, राइट? यू सी क्लोजली।
हाँ
तो अगर तुम्हें पता है कि फंक्शन कॉल कैसे होता है, लाइक स्टैक में कैसे आता है, तो इट्स वेरी इजी टू विजुअलाइज रिकर्शन ओनली, बिकॉज रिकर्शन में भी हम फंक्शन कॉल से करते हैं, ठीक है?
राइट
Similarly, it will pass result to this, then this, then this, then this. Cool. Now let's try to understand time complexity of recursion. That's the thing you asked, right? So is the base condition importance clear, right? Why we need base condition?
हाँ
Now, what do you think will be time complexity of recursion? Time complexity of recursion.
um
So first, try to think what we are actually
well
doing when implementing recursion. Like, what is the internal working happening? So the
so
thing,
we are doing
hmm.
I don't know,
Yeah,
I was just thinking that we're doing the same thing, like not the same thing over and over again, but like we're like doing it again and again. So
hmm.
like it would be a certain thing, certain number of times. Like it would like I feel like it would depend on the number of times you're calling the function,
Correct, correct.
right? Yeah.
तो बेसिकली देखो टाइम कॉम्प्लेक्सिटी ऑफ रिकर्शन क्या होगा, नंबर ऑफ फंक्शन कॉल्स, ठीक है? वॉट एवर
हाँ.
हाउ मेनी फंक्शन कॉल्स यू आर डूइंग, नंबर ऑफ फंक्शन कॉल्स
Mm-hmm.
टाइम्स टाइम टेकन इन ईच फंक्शन कॉल, राइट?
Yeah.
Because that's what essentially you are doing, right? You are calling some functions, है ना? On a
Correct. Yeah.
higher level it is this, you are calling some functions. Now the point is, what will be the time complexity of anything? So the time complexity of any code will be nothing but the number of operations you are doing. So the number of operations will be the number of function calls you are doing, and then what is the time
Yeah.
taken in each function call. You should multiply these two things to get the total time or total operations you are doing, and that's how you calculate the time complexity of recursive function. For example, if we have calculated, like we have calculated factorial 5 here, right? So how many function calls happened?
Fine.
Factorial of 5 called factorial of 4, then factorial of
Yeah.
4 called factorial of 3, then similarly like 2 and then 1, that's it. How many total function calls happened? 5, which is n,
5.
which is n. I is
Correct.
n, right? And then what is the
Yeah.
time taken in each function call? So if you see very like if you see, what are we doing any heavy operation here? No, right? We are just doing multiplication. Are we running a
Yes.
for loop inside it, a while loop? Nothing, right? We are
No.
not doing any
No.
particular operation. So that's why the time complexity of executing a function is constant. Because if factorial of 4 know the result of factorial of 3, it just need to multiply these two things. That's it, right? Which is like the constant time of
Yeah.
we are not doing any heavy
Yeah.
operation inside a function. That's why it is like over 1, and that's why the total time complexity is over n.
Yep. Oh.
Is the time complexity of recursive function clear?
Yes. Yeah.
Okay. So now let's talk about your example, which is like how to calculate time complexity of Fibonacci.
Yeah.
Okay. Or let's discuss Fibonacci in detail again.
Yeah. Okay. Good. Yeah.
So far, any doubt?
No, not so far. No.
Okay. So now to discuss Fibonacci. Okay, cool. So let's say like if we the same thing, we have n, we take n as input from the user and then we print Fibonacci of n. Okay. Now Fibonacci
Yep.
number, first of all we need to understand what is the relation between the functions. The relation between the function is Fibonacci. To calculate Fibonacci of n, you need Fibonacci of n minus 1 plus Fibonacci of n minus 2, right?
Yeah. Yeah.
So I will say okay, in Fibonacci int n. Now I will say return Fibonacci of n minus 1 plus Fibonacci of n minus 2, right?
Yeah. Yeah.
And we also need to write base case. A base case क्या होता है, मैंने क्या बताया था? Smallest valid input. What is the meaning of base case?
Oh yeah. Correct.
Smallest
Smallest valid input. Yep.
valid input that you know.
Mm-hmm.
In case of Fibonacci, what is the smallest valid input?
It's zero.
It's like
Smallest is
0, 1,
0,
1,
1. So it's
right?
0. 0.
Oh yeah.
And then what is the position? 0, then 1, then 2, then 3, then 4. The point is, wait, for this guy, the previous two guys are present. So this is not a base case. Why? Because you can go here, right? You can calculate them. But for them, for these guys, the previous two guys are not present. And that's why they are like your smallest valid input. Because when you will be calculating Fibonacci of n, Fibonacci of 1, what will you say? Return Fibonacci of 0 plus Fibonacci of -1. But -1 doesn't exist, right?
Yeah.
That's why we should like say these two are base cases right now,
Yeah, because they don't use anything.
right?
Okay.
Because their previous two guys doesn't exist, and that's why we have to like separately calculate them. ठीक है? और फिर अगर ये दोनों calculate कर लिए तो फिर आगे वाले तो easily calculate कर ही लोगे, right? With the help of previous
Right.
two.
Yeah.
That's why we will say if n is less than equal to 1, return n, and that's the base case. You can also write this if n is 0, return 0, if n is 1, return 1, but that's the same thing. Okay. So now let's check whether like this function like is working fine or not. So it is working fine, right? It seems correct. Cool. So any doubt in this function?
No.
No.
Okay.
No.
Now let's discuss the time complexity, which is very interesting. So
Yeah.
to calculate time complexity, what we should do? We should check, right, how many function calls are happening, isn't it?
Yeah.
Correct. Yeah.
Okay. So let's say if we are calculating Fibonacci of n, okay?
Yeah.
First Fibonacci of n will get placed, right?
Right.
So now I will be like creating a recursion tree. Recursion tree is nothing but you are like visualizing all the function calls. ठीक है? तो स्टैक में हमने जब विजुलाइज किया था तो सबसे पहले Fibonacci of n यहाँ आया था, Fibonacci of n-1 यहाँ आया था, right? That's one form of visualizing it. But तुम ऐसे भी कर सकते हो ना कि like Fibonacci of n will call Fibonacci of n-1 ऐसा करके,
हाँ.
right? That's मतलब बस visualization का अंदर है, no like concept is same. What I'm saying कि जैसे फैक्टोरियल के टाइम पे मैंने क्या किया था, फैक्टोरियल के टाइम पे मैंने तुम्हें ऐसे बताया था कि लाइक एक्चुअल में जो स्टैक में हो रहा होगा वो क्या हो रहा होगा, वो ऐसे हो रहा होगा कि पहले फैक्ट 5 आया होगा, फिर फैक्ट 4 आया होगा, राइट, फिर फैक्ट 3 आया होगा मेमोरी में, एंड सो ऑन. बट मैं इसको ऐसे भी दिखा सकता
Yeah.
था ना कि फैक्ट 5 से हमने स्टार्टिंग की, फिर हम फैक्ट 4 पे गए, फिर हम फैक्ट 3 पे गए, एंड लेट्स से फैक्ट 3 इज कंप्लीटेड, देन इट विल रिटर्न एंड देन इट विल रिटर्न. जब हम ऐसे दिखाते हैं तो दिस इज व्हाट वी कॉल फंक्शन स्टैक, यू कैन से रिकर्शन स्टैक, और दिस इज व्हाट वी कॉल रिकर्शन ट्री. दोनों सेम चीज है, बट ये वाला थोड़ा ज्यादा इफेक्टिव होता है इन टर्म्स ऑफ विजुअलाइजेशन.
Okay.
ठीक है,
Yeah.
तो ठीक है, let's see like
I-
how many number of calls we are actually
Yeah.
doing, right? Cool. So let's say like we have Fibonacci of n. When we will be calling Fibonacci of n, it will call these two guys, right?
Yeah. Correct. Yeah.
है ना? So first of all let's understand कि मतलब पहले वो recursion stack से ही understand करते हैं, क्योंकि ये थोड़ा सा complex है. Complex इसलिए है क्योंकि यहाँ पे हम दो calls कर रहे हैं. Factorial के केस में we are just calling it like inside a function once, but here we have
Alright,
two
yeah.
function calls, so we need to understand कि what actually internally happens. ठीक है? Let's take a
Yeah.
very simple example. If n is 5, ठीक है, क्या होगा अब मुझे like starting से बताओ. Let's say like Fibonacci of 5 will take place. Now what will happen?
So
Fibonacci of 5
is
क्या
to-
बोलेगा? Fibonacci of 5 will say I need the
that they
result
want Fibonacci of 4
uh,
plus Fibonacci of 3.
3. So now क्या होगा?
So now you would need both of those. So then you would get Fibonacci of 4.
Yeah.
But
Correct.
then to
Basically,
get the
wait. The point is, whenever whenever the guy who is actually allocating these stack memory will see Fibonacci of 4, the guy will ignore Fibonacci of 3 first, because he will say, okay, first let me calculate Fibonacci of 4. I will give you Fibonacci of 4 and then you should execute the rest of your command. Okay. The point is, if whoever is seeing this function call will say, okay, I got the info. You are dependent on Fibonacci of 4. He doesn't know this guy is also dependent on Fibonacci of 3, because it will like work line by line, right? Or in a particular line, it will also like go from left to right. So the point is, first it will see Fibonacci of 4. So it will say, hey, let me allocate Fibonacci of 4. Let me execute Fibonacci of 4. It will not say anything about Fibonacci of 3 because it will get back to it. When you will be returning the result here from Fibonacci of 4 somehow, then the guy will say, okay, you also depend on Fibonacci of 3, let me calculate it as well. आ रही बात समझ में? So both recursion calls एक साथ नहीं होंगे. पहले Fibonacci of 4 पूरा calculate होगा and then like Fibonacci of 3 पूरा calculate होगा. ठीक है?
Yeah.
So now Fibonacci of 4 पे हम आ गए. यार let's first execute this because Fibonacci of 5 depends on Fibonacci of 4 at least, है ना? It also depends on this, but right now we care about only this because first इसका तो result आ जाने दो, then we will calculate the same thing. मतलब we will calculate in the same way. Fibonacci of 4 क्या होगा? Fibonacci of 4 will say I am Fibonacci of 3 plus Fibonacci of 2. So now I will say, okay, you depend on Fibonacci of 3. Let's try to find its value. Fibonacci of 3. Fibonacci of 3 क्या बोलेगा? I am Fibonacci of 2 plus Fibonacci of 1.
But then you would be calculating like Fibonacci of 3 twice. Fibonacci of 3 twice.
That's the problem. Wait. We will discuss these things.
Okay.
Okay. That's not a problem actually. Like you will get the correct result for sure, even if you're calculating it twice. But that's inefficiency. That's not efficient algorithm, right?
Okay, yeah.
And that's what happens when you write it in recursive way. It's not efficient.
Yeah.
Nice observation. Fibonacci of 3 will say, hey, I depend on Fibonacci of 2. Although I also depend on Fibonacci of 1, but first please tell me the result of Fibonacci of 2. So the guy will say, okay, let me allocate Fibonacci of 2 as well. This is what we call like recursive stack, है ना? क्योंकि ये stack memory में क्या हो रहा है ये सब चीज़ें. Fibonacci of 2 अब क्या बोलेगा कि I need result of Fibonacci of 1 plus I need result of Fibonacci of 0. Then we will allocate Fibonacci of 1. So Fibonacci of 1 क्या है? Fibonacci of 1 is the base case. So it will not call anybody, right? देखो Fibonacci of 1 जब तुम calculate करोगे तो if n is 1, it will return 1. It will not call anybody. Fibonacci of 1 बोलेगा कि hey, I got it, like let me return my value. तो यहाँ पे क्या होगा? Fibonacci of 1 will be gone from the memory, and then you will get the result here. Got the point? यहाँ पे 1 आ जाएगा.
Yeah.
What is the next thing? The guy will say, okay, right now my recursive stack, the topmost guy is Fibonacci of 2. That's why I have to execute it completely. Correct? That's the rule. Because stack से जो topmost element है वही like execute हो रहा है function अभी. ठीक है? तो वो whoever is calculating this Fibonacci of 2 will say, okay, so you calculated, you depend on Fibonacci of 1. I have calculated the result. Now what is the next thing? So it will say I also depend on Fibonacci of 0. So it will say, okay, let's call Fibonacci of 0. Fibonacci of 0 will get the memory, and Fibonacci of 0 will say, hey, I am also a base case. Let's return my value. There is no need to call anybody from my side. यहाँ से 0 तुमने कॉल लाइक रिटर्न हो गया और यहाँ पे 0 आ गया. आ रही है ना अभी तक बात समझ में? कोई दिक्कत?
No.
अभी तक everything is clear, right? Fibonacci of 0 भी चला गया. Now you have calculated Fibonacci of 2, which is 0 plus 1. Fibonacci of 2 बोलेगा कि hey, I have calculated my value. Now you can return my value to my parent function. तो parent function कौन है? ये है. यहाँ पे value return होगा. Fibonacci of 2 will be vanished from the memory, and यहाँ पे value आ गई 1.
Right.
अब Fibonacci of 3 बोलेगा कि यार I depend on Fibonacci of 1 as well. Fibonacci of 1 को मेमोरी मिलेगी और लाइक चीजें होंगी और यहाँ पे क्या आ जाएगा? 1 आ जाएगा. And Fibonacci of 3 will get its value, which is 2. It will return its value to its parent function, which is 4 यहाँ पे. ठीक है ना? And that's how like चीजें calculate होती हैं. यहाँ पे आ गया. And Fibonacci of 2 का value हम already like निकाल चुके हैं, but same process यहाँ पे repeat होने वाला है, right? The same thing will repeat here. You have already calculated Fibonacci of 2, but the same thing will repeat here. अब फिर से like Fibonacci of 2 यहाँ आएगा, फिर ये like 1 को कॉल करेगा, फिर 0 को कॉल करेगा, and then अपनी वैल्यू निकालेगा. तो वो चीज़ें तो होंगी.
Yeah.
Fibonacci of 2 will say okay I am 1. ठीक है,
Okay.
वो सारी चीजें हो गई, उसके बाद रिटर्न हुआ. ठीक है, आई एम नॉट शोइंग
हाँ.
एवरीथिंग.
Right.
Now
Yeah.
Fibonacci of 3 gets its value, Fibonacci of 4 gets its value which is 3, it will return here, है ना, and it will
Yeah.
be like
Yeah.
gone from the memory. तो यहाँ पे आ गया 3, यहाँ पे आ गया 3. फिर Fibonacci of 3 फिर से कैलकुलेट होगा, जो प्रोसेस हुआ था वो फिर से कैलकुलेट होगा, और यहाँ पे like Fibonacci
Yeah.
of 3 कितना होता है, 2 होता है, तो वो फिर जैसे तैसे रिटर्न
Yeah.
होगा. And that's how you will be calculating Fibonacci of 5, which is 5.
Yeah.
And that's what internally happens, right? तो अगर तुम्हारे पास दो फंक्शन कॉल्स भी हैं, if you are calling a function in like more than one time, so whatever comes first will be executed. ठीक है,
हाँ.
will be executed fully, and then it मतलब फिर इसकी बारी आएगी. ऐसा नहीं होगा कि दोनों को एक
Yeah.
मतलब दोनों को एक साथ कॉल कर दिया, ऐसा नहीं होता. पहले इसका वैल्यू पूरा कैलकुलेट होगा, फिर इसका वैल्यू पूरा कैलकुलेट होगा. So if we create the recursion tree for Fibonacci, let's see what is happening. So Fibonacci of 5 will say, ठीक है, Fibonacci of 5 will say, or let's, हाँ ठीक है, Fibonacci of 5 will say, I am dependent on Fibonacci of 4 and I am also dependent on Fibonacci of 3, right?
Yeah.
And then पहले क्या होगा, लेफ्ट वाला पहले पूरा कैलकुलेट होता है, पहले लेफ्ट वाला ट्री पूरा कैलकुलेट होगा, and then we will come to Fibonacci of 3. ठीक है, this is a recursion tree.
Okay. Yeah. Yeah.
Fibonacci of 4 बोलेगा कि I am dependent on Fibonacci of 3 and I am also dependent on Fibonacci of 2. पहले क्या कैलकुलेट होगा, पहले 3 कैलकुलेट होगा, because it is the left. ठीक है, फिर Fibonacci of 3 बोलेगा I am dependent on Fibonacci of 2, then I am also dependent on Fibonacci of 1, and then similarly like ये बोलेगा Fibonacci of 1, Fibonacci of 0, और ये बेस केस है तो ये सीधा रिटर्न हो जाएंगे यहाँ से, है ना.
Yeah. Yeah.
और similarly like Fibonacci of 2 यहाँ पे फिर बोलेगा I am dependent on Fibonacci of 1, Fibonacci of 0, and similarly Fibonacci of 3 यहाँ पे फिर से रिपीट होगा, like whatever you have done here it gets repeated here, like ये पूरा प्रोसेस यहाँ पे रिपीट होगा
Correct.
to calculate Fibonacci. Let me
Yeah.
create it as well. Fibonacci of 2 and Fibonacci of 1, and then like 0 and sorry 1 and 0. ठीक है, अब to calculate its time complexity, what should we do? How to calculate its time complexity? Time complexity कैसे निकालते हैं recursive function का? Yeah, let's see what are the
The
total
number-
number of recursive calls we are doing, right?
How many calls? Oh yeah.
Yeah, that's the same thing. That's the very basic thing. How many calls we are doing? Times, what is the like time taken in each calls? If you see very closely, here n is 5. So we have got roughly like 5 levels. 1, 2, 3, 4 and 5. 5 levels roughly मिले ना हमें.
हाँ.
And 5 से ज़्यादा levels मिल सकते हैं क्या? The answer is no, because if you look very closely, in each level you are going one value down, right? One value less.
Yeah.
So you cannot go further beyond 5 levels, because otherwise value जो है 0 हो जाएगी, और 0 is the base case.
Right.
Now let's try to look. So this is a tree, right? This is what we call a tree. कि tree क्या होता है? Let me give you a very basic example, because I don't think so you know tree. Tree में तुम ऐसा बस समझो कि एक root होता है, ठीक है? फिर उसके childrens होते हैं.
हाँ.
Like ये हो गया, ये हो गया. फिर इनके भी childrens होते हैं. That's it. मतलब ऐसे करके जो चीज़ बनती है इसको हम tree बोलते हैं. अभी के लिए इतना introduction काफी है. This is also a tree if you look closely. The left side figure. ये भी तो tree है ना? पूरा.
हाँ.
Okay. Now let's try to see what are the total number of nodes in it. Nodes का मतलब क्या हुआ कि ये, which is nothing but recursive calls, है ना? ये सारी चीजें क्या है? Recursive calls है ना?
Oh yeah, recursive calls. Yeah.
And let's call it, if we are saying the whole structure is a tree, so they will be particular nodes of tree. Nodes means the entity of tree, one entity, right?
हाँ.
Let's see how many total number of nodes we have. So in the first level we have 1, then in the next level we have 2, in the next level we have 4, then we have 8, and so on. The point is, every node will give 2 nodes, will give birth to 2 children. So the point is, if you
Yeah.
have one node at the first, it will give birth to two childs, so two children, and then both of these two children will give further two children. So you will be having four children, then you will be having eight children, and so on. The point is कि यहाँ पे डबल होती जा रही है
Yeah.
चीजें, राइट? वो तो अच्छा है, यहाँ पे रुक
हाँ.
गया, अदरवाइज यहाँ पे कितना आता? 16 आता. लेट्स से अगर
Yeah.
फिबोनाची ऑफ 10 हम कैलकुलेट कर रहे होते तो यहाँ पे 16 नोड्स होते हैं, एंड देन 32 नोड्स होते हैं, एंड सो ऑन. आ रही है बात
हाँ.
समझ में?
Yeah.
So the point is कि how many total number of recursion calls we are doing?
It's total of 2 to the n 2 to the 5.
It is nothing but in this case 1 plus 2 plus 4 plus
More
3.
like that. Yeah.
Let's ignore these two, ठीक है?
So 2 to the
So the point is 1 plus 2, or you can say 2 to the power 0 plus 2 to the
2
power
to the
1
power
2 to the power 2 plus 2 to the power 3.
Oh.
So if n is 5, we are doing up to 2 to the power 3 operations. Like up to summation of 2 to the power 3, which is how much?
2 to the 2 to the
This is what we say, this is a GP, right?
14, 15.
No, but like what will be the general term for this? It will be, I guess, 2 to the power 4 minus 1, or you
2
can
to the
say
power n.
हाँ, मतलब 2 to the power 4 minus 1 है ना?
Yeah.
If you look closely, if n is 5, we are doing around 2 to the power n minus 1 operations.
N minus 1, yeah.
So the point is, the time complexity is, for a particular n, the time complexity is roughly big of 2 to the power n. It is 2 to the power n minus 1, but roughly 2 to the power n. So the point is कि the time complexity to calculate Fibonacci of n using recursion is exponential. This is what we call exponential time complexity,
Yeah.
which is very, very bad. Because if you do it iteratively, you can achieve the time complexity of order of n, right? Because I can also do it iteratively. Iteratively कैसे होगा? Fib iterate int n. To calculate it iteratively, I can say if n is like less than equal to 1, return n. Otherwise, I can make two variables. ठीक है? A is 0, B is 1.
Yeah.
And then
I
like,
actually did it both ways.
okay. So now we know कि we are calculating till I n, ठीक है?
And I plus
And then हम क्या बोलेंगे यहाँ पे?
we have a
कि let's calculate one more thing.
so it will be the answer. So we have a final answer which will be equal to like the previous
C
number
is A
plus
plus B.
previous
Okay,
number.
C is A plus B. And now in the next iteration, your A will become B and B will become C. अब ये आया समझ में क्या किया मैंने?
Yeah, I do.
देखो, मैंने क्या किया यहाँ पे कि हमें पता था कि लाइक फिबोनाची सीरीज क्या होता है, 0 1 1 2 3 5 ऐसा करते हुए. सबसे पहले मैंने क्या बोला कि दिस इज A, दिस इज B. Now I'm calculating these guys. Let's say this is n. Okay, this is the nth guy. So I'm saying this is the second guy. So I will be starting the loop from second guy, because I'm right now calculating the second guy, and I have to calculate it till nth guy. So second guy क्या हो जाएगा? A plus B. So this is A, this is B. So A plus B, which is 1. Now when you will be calculating this particular element, your A should be this and B should be this. This is your C in the first iteration. So now you should say that your A will become B and B will become C. That's what I did. A will become B, B will become C. That's it. Like you need to like return C here. So we can also like call fib iterate, and we can see on 7 we are getting 30. इसमें कोई दिक्कत है fib iterate में?
No.
No. So what is the time complexity of fib iterate? It is order of n, right? But what is the time complexity of recursive fib?
2 raised to the n.
2 raised to the power n, and that's actually very bad, right? If you are comparing order of n versus order of 2 to the power n. So for higher values of n, let's say if n is 100, so you will be doing only 100 operation here, versus you will be doing 2 to the power 100 operations here, which is too much. 2 to the power 100 is too much. I think you won't be able to do it inside, like in your machine. 2 to the power 100 is like 10 to the power 30.
Too much, yeah.
So this is how that bad this algorithm is. I mean, if you solve it using recursive way, if you solve Fibonacci using recursive way. So why we got 2 to the power n time complexity? What is the reason for that? The reason is you already figured out. The reason is we are doing same calculation again and again, right? That's what you told me, na? why we are doing same calculation again, and we cannot stop it, like we have to do it.
We have to do it like that,
तो
yeah.
बेसिकली देखो, अगर तुम यहाँ पे ध्यान से देखोगे तो ये फिबोनाची ऑफ 3 का ट्री है, और ये भी फिबोनाची ऑफ 3 का ट्री है, which is the same thing, and still you are calculating the same thing again and again. So in recursion this actually happens. You calculate same thing again and again, and to stop it we use memoization, and the whole concept becomes dynamic programming, or you can say recursive DP. This is what the concept of DP is. Ki using DP, you will say, okay, you have already calculated Fibonacci of 3. Let's store it somewhere. We have already calculated Fibonacci of 3 with this value. So now when you will again call the recursion function of Fibonacci of 3, it will say, hey, stop here right now. I have already know the value. You can directly return it. Are you getting the point? That is what the meaning of memoization. If we store the results and
Yeah.
use them whenever needed, and that's the concept of recursive DP. But the point is, for this session, there is no point of going deep in recursive DP. I'm just telling you what is the fault in recursion and why we like fix it, and we call it like recursive DP or dynamic programming in general. Okay, that's why we got 2 to the power n very worst time complexity, because we are calculating the same thing again and again here. Got it?
Yep.
Good. That's how. So got the point how we calculate time complexity of recursive functions?
Yeah, now I understand.
So basically, for the time being, you should create this recursive tree and try to see what are the total number of nodes we have. Got the point?
Okay.
Create the recursive tree, not the stack, because stack में तुम्हें पता नहीं चल पाएगा ना कितने nodes तुम कर रहे हो, because वो तो like it is happening internally, but वो तो ऐसे करके like उसमें तुम पता कैसे लगाओगे, या तो तुम count करते जाओ, but that's a very bad idea कि सारे stack calls count करें. इससे अच्छा है कि देखो ये tree बना के देख लो. Let's say Fibonacci of 5 में ये tree बन रहा है, तो अगर let's say for higher number of n, the tree will look something like this कि पहले 1 आएगा, फिर 2, फिर 4, फिर 8, ऐसे करके like इतने nodes होंगे हर level में. And if it is a tree, you can like do it level by level, है ना, क्योंकि trees में level होते हैं, tree में level होते हैं. Level क्या होता है? Level कुछ नहीं होता. Let's say कि this is your root. इसके children will become the further level. Then इनके children will become the further level. तो this is one level, this is one level, this is one level, then this is one level. ऐसे करके level wise देख सकते हो तुम tree. You can visualize tree level wise. Got the point?
Yeah. Yep.
Oh. So cool. So internal working of recursion is done. Okay. So now let's talk about how we actually write recursion for any solution that can be solved using recursion. Yeah. For any problem that can be solved using recursion. So how we actually write it? What is the thought process? अभी तो काफी सिंपल चीजें की हमने कि फिबोनाची कैलकुलेट करना है या फैक्टोरियल करना है, जो कि हमें ऑलरेडी पता है कि इनका रिकरेंस रिलेशन एग्जिस्ट करता है ना. और लेट्स से किसी प्रॉब्लम में यू डोंट नो द रिकरेंस रिलेशन, हाउ टू एक्चुअली क्रिएट द रिकरेंस रिलेशन इफ इट इज पॉसिबल. So now we will discuss what are the approaches we should have or we should like learn to solve recursion problems. There are mainly two approaches.
Okay.
There are mainly two approaches to solve recursion problems. Okay. First thing, like it depends. So let's say कि first thing is induction based hypothesis method. You can say there are mostly two methods, mainly two methods to solve recursion problems. अगर ये दोनों methods तुम्हें आते हैं, so you will be like able to solve recursion problems. ठीक है? So in today's session, we will be discussing about induction based hypothesis method, and the second method is like kind of input output method. This is a very vague name, but input output method. This is the name you can just you can remember right now. What is this IBH method? So ये एक method है using which you can solve recursion problem, or you can say this is the way of thinking you should have while solving a recursion problem. Okay, that's how you should think, or that's how you should like build your solution. IBH का मतलब होता है कि this is like induction, this is I, base and hypothesis. Okay. Any doubts?
No doubt so far.
Okay.
No.
This is one method,
Okay.
and this is another method. So we will discuss this method in like our further session. But for the time being,
Okay.
today we will be discussing about IBH method, how to solve problems using IBH method, which is induction
Okay.
based hypothesis. So let's see
Yes.
first what these terms are: induction based and hypothesis. So first discuss hypothesis. What do we mean by hypothesis? Hypothesis means defining the work of your function. Defining the work slash functionality of your recursive function. We will see what do we mean by this, of your function.
Okay.
Base means, you already know what base means. Base means writing base case. And base
Yeah.
case means smallest valid input. ठीक है, smallest valid input जो भी है उसको like लिख दो कि यहाँ पे you should stop. You should not go further beyond this because there is we cannot calculate it. Otherwise it will become a stack overflow. ठीक है. The first step you should do whenever you are solving a problem is defining the hypothesis or creating the hypothesis. Hypothesis का मतलब है defining the work of your function. कि hey function, you should do this. It's your job. For example, in case of factorial, I told right कि its job is to calculate factorial of n. That thing is called hypothesis. You have actually defined the functionality, what it should do. Second thing is you should be able to think of a base case because base case is necessary. And the third thing is which is induction. अब induction क्या है? Induction you can think of is finding a recurrence relation, or you can say finding a relation between functions. और इसको और अच्छे से ये बोल सकते हैं dividing your problem into smaller similar problems.
Okay.
For example, if we take the case of अभी ठीक है ये तीनों definitions देख लो. अब let me explain क्या है. In case of factorial, calculating factorial number of any particular guy, the hypothesis will be कि hey factorial, your job is to calculate factorial of n. So if I pass factorial of n, its job is to calculate n factorial. That's hypothesis. That's it. What is the base case? The base case is what is the smallest valid input. So you can say like if we have 1, if n becomes 1, you should return 1. That's the base case. What is the induction? The induction step is dividing your problem into smaller similar subproblems. Okay? Smaller problem plus doing some self work. तो ये इंडक्शन है. इंडक्शन का मतलब होगा कि you will be doing some self work, like थोड़ा सा काम तुम करोगे अभी, and then you will say कि hey, like I should divide this problem into smaller sub problem, I should delegate this task. For example, in case of factorial, what you did, to calculate factorial of n, you said okay, I will be doing a multiplication between these two, n into factorial of n minus 1. So this small work is your small work, doing some self work, and you have delegated your work into like another similar sub problem. तुमने क्या बोला? तुमने ब्रेक कर दी प्रॉब्लम. तुमने बोला कि यार this calculating factorial of n is very difficult task for me, so first calculate n minus 1 factorial for me. Hey, please calculate n minus 1 factorial for me, and if I have n minus 1 factorial, I can easily calculate n factorial. तो ये जो factorial of n minus 1 तुमने बोला, ये तुमने क्या किया? तुमने you have divided your problem into smaller sub problem, smaller similar sub problem. That's important. ठीक है, similar होना चाहिए. ऐसा नहीं होना चाहिए तुमने कुछ और ही प्रॉब्लम डिफाइन कर दिया. ऐसा नहीं, जो अभी प्रॉब्लम चल रहा है उसी का स्मॉलर वर्जन होना चाहिए. इफ यू सी फैक्टोरियल ऑफ n कैलकुलेट करना था, उसका स्मॉलर वर्जन क्या हो सकता है? फैक्टोरियल ऑफ n minus 1 कैलकुलेट करना है, राइट? एंड यू हैव डिवाइडेड योर प्रॉब्लम, राइट? तो ये तुमने थोड़ा सा सेल्फ वर्क किया. सेल्फ वर्क क्या था कि मल्टीप्लिकेशन करना है इन दोनों का, और तुमने क्या बोल दिया कि यार फैक्टोरियल ऑफ n minus 1 मेरे को ला के दो. यू हैव टू टेल मी द रिजल्ट, आई डोंट नो. एंड दैट्स हाउ रिकर्शन वर्क्स. You first define your task, like define your functionality of your function. You write the base case, and then you try to divide your problem into a smaller version of itself. क्योंकि smaller version of itself जो है वो तुम delegate कर सकते हो. You will say, hey, factorial of n minus 1, your job, right? It's your job to tell me the factorial of n minus 1. I don't care how you will calculate it, but I need that. So factorial of n minus 1, since तुमने define कर रखा है इसको hypothesis में, it will do whatever you have defined. And that's how recursion works. That's why people like have a lot of difficulty in understanding this, because recursion works like magic. तुम इसको जो बोलोगे ना वो वही करेगा. Whatever you will write, whatever you will define it, it will do the same thing. ठीक है. So
Okay.
for example, let's see. अब देखो कितना interesting चीज हम करते हैं.
Hmm.
Now print 1 to n. What? Anything?
Oh no, nothing, nothing.
Okay. So yeah, ये चीज clear है ना थोड़ी थोड़ी तो कि first we need to define its functionality, which we call hypothesis. First you need to define the hypothesis, then you need to find out the base case, and then you need to do induction. Induction step is breaking your problem into a smaller version of itself. ठीक है? Doing some self work, because if you don't do self work, how will it break into smaller version, right? You have to do some work,
Yeah.
right, at this point.
Yeah.
Then your problem will become the smaller version of itself.
Mm-hmm.
And if you're able to do this thing, then you can go ahead and apply recursion, and you can solve that particular problem using recursion. Okay, let's see. The task is very simple. Given n, you need to print numbers from 1 to n. For example, like if n is 5, you need to print, right? If n is 5, then you need to print 1, 2, 3, 4, 5. Now, obviously, we can do it using a simple for loop, but right now we will be trying, like we are trying to solve it using recursion to understand how we can apply recursion to solve very easy problems, and then we will like gradually move, like we will gradually increase the difficulty level of problem. Okay. So right now,
Okay.
like you can print 1 to 5 using a for loop, right? Simply. But now let's try to do it using recursion. Okay. So that's the problem. Ki, given n, print from 1 to particular n. For example, if n is 5, the output, so this is your input, this is your output. Got the point?
Yes. Yeah.
Okay, so now let's think about it for a minute. I'll get back into it. So like in your particular machine or your laptop, you should write a recursive function which do this. Given n. So basically I will be calling a function, okay, यहाँ पे, like cout fun, or maybe like I will be calling it just this, an n, and this function functionality or its hypothesis should be, hey, you should print from 1 to 5 or from 1 to n.
Okay.
Yeah, and like you can take a look here as well. I'll be back in 2 minutes. Yeah. So, हो गया?
So, yeah, hello.
Yeah.
Yes. So, yeah, I think,
Okay. Share your code
um,
in the chat. Like, just share your function
yeah,
definition.
okay, well, found it. What do you want me to tell you? Just what's inside my function, right?
Yeah, I mean like your entire function definition. I mean, let's say this is your function. So you should share whatever like from this line to this line. You should share the entire function.
Okay.
What about Arini?
Yeah.
You also
Um,
want to do?
so yeah. Um, I was able to figure out like a little bit of it.
Mm-hmm.
Um, I can share that. Give me a second.
Yeah. So just share your function definition of whatever you have written. At
Yeah.
yeah, Rohit. I didn't.
Just to
Hello.
copyright this.
Yeah.
Yeah. I don't know what.
Did you guys get my thing
Oh, where did you send it?
on the chat? Right?
Oh,
Uh,
are you the
It's
WhatsApp
like
chat?
white.
Aravi, did you run it? Is it working fine? You can also run it, right? Since you were writing that code in initial.
No, I didn't run it.
Then how do you know it is like good?
I just tested by hand.
Okay, your function.
Let
Um,
me open.
okay. So are you able to see my screen
That's
right
what.
now, both of you?
Yeah. Yeah.
Hmm. So first of all, in which language you have written this?
Yeah, I started using C++. My head went to Python. I don't know why. I didn't mean to. I've just been going back through languages this week. That's why.
Yeah,
Sorry.
even that's the same case with me. In my job, I am working on Python, and here when I teach, I'm working on C.
Yeah, we had like a Python final and a Java project due at the same day, so I was just
That's
working
that's
between
completely
those two.
fine. Like there is not much difference, right? Like तुम change कर ही सकते हो obviously. So this is your function, right? ROV.
Yeah,
Do you think it will work fine?
I think so.
She's probably missing the base case. I'm not sure,
You
maybe
are
because
missing.
that's what I had, but I don't have the base case, so that's probably the reason. Maybe I don't know.
Okay. So ROV, do you think this will work fine? Like this will. So
I
basically, I will provide an input. So let's say to simplify things, let's not provide the input. Let's just define it. So let's say input is 5. So I should get 1, 2, 3, 4, 5 in my screen. So will I get?
I'm pretty sure.
You are pretty sure, but you haven't written any cout statement. So how will you get the output? First, tell me this. You haven't
What do you
written any
mean I
print
haven't?
or cout statement.
Aravi, yeah, it's not Python, so you can't just return from a function. You need to write C out.
No, even if it is
Oh,
Python, okay.
right.
Even if it is Python, will it print everything?
I mean, you'll need a print statement in the main function, like print fun of and yeah.
Yeah, wait. Even if it is
Wait, I'm
Python,
confused. What?
wait, Arohi, no need to like confuse. What I'm telling is, see, are you sure this will like work fine? So basically, what I should get Arohi in my output? First, tell me.
1, 2, 3, 4, 5. That's what
Yeah,
we want.
yeah. Now tell me one thing. To get 1, 2, 3, 4, 5, we should also print them, right? Somewhere.
Oh, we have to print and
Yeah,
after the wait, wait, can you remove, you know what, I'm gonna send a new one
yeah,
second.
yeah. Please do.
Um, so if we do like This should work. Sure. Maybe like this. Let me test it. Code I sent was this. So I'm testing it now, and
Okay.
oh yeah, I use print again. Yeah, fun. Let me test it 1 second.
Yeah.
So input would be what?
I think you should also like share your code as well.
I did.
Wait, so Arohi
That's
shared,
wait.
right?
There's a lot of syntax errors. I'm just trying to figure.
Yeah. Arni, you should also share your code.
Okay, mine's like the same thing. I just changed it to see out, but sure.
Printf.
Did you
Whatever.
copy from Arohi's code?
No, like that's just the basic things we already learned.
Yeah,
So
that's joking.
Printf.
also, mine's on the iPad, like the call, but I'm doing the code on my laptop.
So it's okay, like
So
there is no need to. Yeah, Arohi, are you like doing some
I'm trying to
activities?
test it.
No,
Yeah,
I'll
even
test it.
mine's thing.
I'll test it. Just share whatever you have written.
Okay, I did right. Wait,
Okay.
I'm just gonna send
Right?
it again.
you forgot to just change the see out, but yeah, you
It's
said the
okay.
same
It's
thing
okay.
again. But yeah, that's fine.
It's okay. I'll
That's
I'm
fine.
sorry.
I'll change it.
It's fine.
Okay, so this is your function, right? Now, first of
Yeah.
all, okay, so let's see. So what I told you, how you should like think about a building approach. The first thing is, first thing क्या करना चाहिए हमें? Whenever we have a problem, hypothesis, correct. What is your hypothesis? Hypothesis means defining the function, like defining its task.
Yeah.
Hey, function, it's your job. Do. So let's say if we
Yeah.
have function of n, what its job is, Arohi?
The function of n is to print out
Yeah.
the numbers from 1 to n.
1, 2, 3
Two.
till n. It's your job, right? This is hypothesis. Okay? Correct?
Yeah.
Now, what is the base case? The base case, what is the base case? Base case is smallest valid input. So, smallest valid input क्या होगा?
Yeah,
Smallest value would just be. Wouldn't it just be?
हाँ पूरा बोलो. There is no need, like, be
Wouldn't it just
confident.
be 1?
Correct, it will be 1 because function of 1 का task क्या है? To print 1. Function of 0 का task क्या है? To print nothing, and function of 0 should not be called. That's why we will say function of 1 will be smallest valid input. This is your base case.
Yeah.
And what is your induction step? Now, induction is very important. Induction मतलब how you are dividing or breaking your problem.
Yeah.
तो अब देखो ध्यान से, रुको. अब इंडक्शन स्टेप देखते हैं. देखो फंक्शन ऑफ n की रिस्पॉन्सिबिलिटी क्या है? टू प्रिंट फ्रॉम 1, 2, 3, 4 till n. Or let's say let's take value here. So let's call it like 10. तो हमने बोला कि 1 2 3 4 टिल 10 तक तुम्हें प्रिंट करना है। लेट्स टेक अ स्मॉलर वैल्यू, इतना बड़ा वैल्यू लेने से भी कोई मतलब है नहीं। लेट्स टेक 5। तो फंक्शन ऑफ 5 का बात यह है, मैंने बोला ठीक है, लेट्स ट्राई टू डू सम सेल्फ वर्क एंड लेट्स ट्राई टू डेलीगेट आवर वर्क और लेट्स ट्राई टू डिवाइड द प्रॉब्लम इनटू स्मॉलर वर्जन ऑफ इटसेल्फ। तो मैंने बोला कि ठीक है यार, फंक्शन ऑफ 5 का लाइक टास्क है टू प्रिंट, लाइक इट्स जॉब इज टू प्रिंट फ्रॉम 1 to 5, विच इज अ डिफिकल्ट जॉब राइट नाउ फॉर मी। तो मैं ये बोलूंगा कि ओके, if somehow somebody does this particular thing for me, which is printing from 1 to 4 and which is nothing but the job of function of 4, right?
Oh yeah.
The
And
point
I keep
is,
doing that, yeah.
yeah, it will keep recursively keep doing that. तुम्हें
Hmm.
उतना दिमाग नहीं लगाना है। What I told you, recursion works like magic. तुम जो इससे बोलोगे, whatever you will tell the recursion to do, it will do the same. Because it depends on your hypothesis and your induction. अगर तुम बस ये एक स्टेप में अगर तुम समझ जाते हो, जस्ट इन वन स्टेप, कि तुम सही चीज कर रहे हो, तो इट विल कीप ऑन डूइंग द सेम थिंग करेक्ट रिकर्सिवली। यू डोंट नीड टू लाइक थिंक अबाउट दैट, ठीक है, यू जस्ट नीड टू थिंक अबाउट दिस पर्टिकुलर वन स्टेप। एक स्टेप में हम सही जा रहे हैं। तो तुम क्या बोलोगे कि टू एक्चुअली do the job of function of 5, I can call function of 4 and then I can print after calling function of 4, then I can print 5। तो फंक्शन ऑफ 4 क्या करेगा? फंक्शन ऑफ 4 का जॉब है यार, वो तो 1 2 3 4 प्रिंट करना, उसके बाद में 5 प्रिंट कर दूंगा, एंड दैट्स द होल थिंग विल बिकम जॉब ऑफ फंक्शन ऑफ 5, isn't it?
Yes.
तो इंडक्शन स्टेप क्या होगा कि फंक्शन ऑफ n is nothing but first call function of n minus 1 and then print n. This is your induction. And if you are able to define the hypothesis, the base case and induction, it means you have solved the problem. That's it. अब तुम्हें बस code लिखना है, and writing code is very easy. If you have done these 3 steps, then writing code is very easy. So this is your code, ठीक है Aruvi? So let me write function. Do you write double A or like single A?
Yeah, double A.
And let me write my function. So first of all, Aruvi, tell me one thing. Why is the return type is int?
What?
Why the return type of your function is integer? What it is returning? Do we really need to like return something? We are just calling it.
No.
We are not using the value.
No. We don't need to return. It's just
We don't need to return anything, right? Because its functionality is to print something.
I'm just in the habit, yeah.
So let's write function. Let's call it fun. Now the first thing is its job, right? So let me write its job and comment. Your job is to print from 1 till n. I'll say okay. Now let's write the induction first. Okay, you can also write the base case, but it's up to you. Like induction क्या है? Induction तुम बोलोगे कि like first let's call function of n minus 1. So its job क्या होगा? Hey, your job is to print from 1 to n minus 1. अब अगर 1 to n minus 1 किसी ने तुम्हारे लिए प्रिंट करके रख दिया है, तो तुम एटलीस्ट n तो प्रिंट कर ही सकते हो ना। तो I'll say yes, I can print n, and this is your small self work. That's it. Now obviously you need to write base case, otherwise you'll get into infinite recursion. So base case लिख देते हैं. Base case will be if n becomes 1, or you can say directly if n becomes 0, there is no need to do anything and you can return. That's it. Otherwise तुम ये भी बोल सकते हो कि if n is 1, एक तरीका तो ये हो सकता है बेस केस लिखने का कि अगर n 0 हो गया, there is no need to do anything, ठीक है, तुम just return कर दो। Otherwise तुम ऐसे भी कर सकते हो if n is 1, print 1 and return. But I find the previous one better क्योंकि वो थोड़ा ज़्यादा अच्छा दिख रहा है। That's why हम ऐसे लिखेंगे कि if n is 0, return. That's it. तो देखो अब देखते हैं इंटरनली ये वर्क कैसे कर रहा है, ठीक है, फंक्शन। लेट्स सी, तो फंक्शन इंटरनली वर्क कैसे कर रहा है। तो हमने लेट्स से फंक्शन ऑफ 5 कॉल किया। फंक्शन ऑफ 5 क्या बोलेगा कि लेट्स कॉल फंक्शन ऑफ 4, लेट्स कॉल फंक्शन ऑफ 4। फिर फंक्शन ऑफ 4 क्या बोलेगा, देखो ये वाला प्रिंट स्टेटमेंट नहीं चलेगा बिकॉज फंक्शन ऑफ 4 आ गया एब्स्ट्रैक्ट के ऊपर। तो फंक्शन ऑफ 4 जैसे कि अगर लेट्स से ये फंक्शन ऑफ 5 है, फंक्शन ऑफ 5 में क्या है बेस केस है तो बेस केस तो हिट नहीं हुआ बिकॉज n is 5, देन इसने कॉल कर दिया फंक्शन ऑफ 4 को, तो ये वाला जो स्टेटमेंट है अभी रुक गया है, फंक्शन ऑफ 5 एग्जीक्यूशन विल बी पॉज्ड, ठीक है, बिकॉज नाउ इट हैज कॉल्ड फंक्शन ऑफ 4, तो अब फंक्शन ऑफ 4 चलता रहेगा, एंड जब तक फंक्शन ऑफ 4 कंप्लीट नहीं होता फंक्शन ऑफ 5 फिर से स्टार्ट नहीं होगा. यू नो दिस राइट, आई होप, आई मीन आई हैव डिस्कस्ड इट ऑलरेडी.
Yeah.
ओके, फिर सिमिलरली फंक्शन ऑफ 4 आया, फंक्शन ऑफ 4 फंक्शन ऑफ 3 को कॉल करेगा, देन फंक्शन ऑफ 2 को कॉल किया जाएगा, फिर फंक्शन ऑफ 1 को कॉल किया जाएगा, और फिर फंक्शन ऑफ
Yeah.
0 को कॉल किया जाएगा विच इज बेस केस, इट विल से
Yeah.
रिटर्न,
Yeah.
डू नथिंग. फिर फंक्शन ऑफ 1 क्या करेगा, ओके फंक्शन ऑफ 0 इज फिनिश्ड, नाउ वी नीड टू प्रिंट 1, तो फंक्शन ऑफ 1 प्रिंट कर देगा. सिमिलरली फंक्शन ऑफ 2 बोलेगा फंक्शन ऑफ 1 इज फिनिश्ड, लेट्स प्रिंट 2, देन ये बोलेगा 3, फिर ये बोलेगा 4 एंड ये बोलेगा 5, एंड दैट्स हाउ लाइक 1 2 3 4 5 विल बी प्रिंटेड.
Yeah.
Got the point? So let's see whether this
Yep.
whether this like function is working fine or not.
Okay.
1 and my क्या बोल रहे हैं? 1 was not declared.
I think there's a parenthesis here.
what is the exact error? 1 was not declared. Oh wait. In your function, like we need to like comment it. Because there is a compilation error, na? Because its function name is like fun ROV and we are
Yeah.
calling fun inside it. So that's okay. So we are getting 1 2 3 4 5, right? And what you can do is to get the better output, you can just print a new line after it. You are getting this. You can also take input from the user. So let's say if I write 10, it will be printing 1 2 3 4 5 6 10. Got the point? So ऐसे step by step चलना है. First, what I did was defining the hypothesis, then getting the base condition, then doing the induction step. अगर ये तीनों चीजें हो गई हैं तो फिर writing the code is very easy. और यहाँ पे तुम बोल सकते हो like 0 लिख दो, ठीक है? To get a clarity, which is smallest invalid or you can say largest invalid input. तो दो चीजें कर सकते हो तुम, या तो स्मॉलेस्ट वैलिड इनपुट या लार्जेस्ट इनवैलिड इनपुट. बिकॉज लेट्स से अगर ये तुम्हारा इनपुट है, ये तुम्हारा इनपुट लाइन है, दिस इज योर 0, दिस इज योर 1, तो ये सारे लोग वैलिड हैं और ये सारे लोग इनवैलिड हैं इन दिस केस, राइट? तो तुम ये क्या, या तो तुम इसको लिख सकते हो कि यार यहाँ पे जब पहुंच जाओ तो यू शुड स्टॉप, यू शुड डू योर जॉब एंड देन स्टॉप, और या फिर तुम ये वाला लिख सकते हो कि यू शुड स्टॉप, दैट्स इट, बिकॉज देयर इज नो जॉब हियर.
Yeah.
It's up to you how you write. So for this case, I have written this, which is the largest invalid input, which is 0, because यहाँ पे तो -1 -2 ऐसे आ जाएंगे ना. So this is the largest invalid. Got the point?
Yeah.
Okay, now let's see Arohi's function ki what she did. So let's say now I am commenting my code. Let's say your function name is fun, right? And let's call it. Let's see what happens. So first of all, there is no need of this int, but still, let's call it. And print is not declared. Okay, so let's write C out here. Now, warning, no return statement in function here. So, okay, Arush, your code is also working fine. So you also did the same thing. If we see, you are first calling function of n minus 1 and then you are printing n, which is good. But the point is that there is no need to write like this. I prefer writing this. If n is 0, you also return the same thing. Na? If n is greater than 0, then you should do this. Instead, what you can do is if n becomes 0 or if n hits an invalid case, you directly return. That's it. Right? It is better. It is better, like
Yeah.
in terms of readability. So I prefer writing this way. Okay, and the point is it is giving me an warning. Can you tell me why this warning we got? No return statement function returning void.
Oh, because if you go back to the function, I started off with like int, so I'm supposed to have a return because it like I'm telling the function's definition that it has to return an integer. So since I'm not returning integer, it's saying like
So if we write a return statement here, what will happen? Is it good now?
no, it needs to be like outside of the if statement. Like we need to have some kind of return statement, like for the actual function, I think. Yeah, like some kind of return statement
What should I
there.
write here?
Um, return
If
return fun of
Return.
wait.
no, actually the point is there is no need to return anything. But still, since you are like returning something, what should we return? If we return 0 here, will the function work? Like, will the code work?
No.
No? Let's see.
If we return 0,
It is still working.
yeah,
See, it is still
I
working.
mean we're just returning.
If we return any random value, let's say like if we return this,
I think it will still work.
yeah, it will still work. Because there is no point of, we are not using it anywhere.
Yeah,
Even
that's
though you are
true.
returning some value, this function will return some value, but
We're
we are
not
not using
using,
it anyway.
yeah, we're not using return value.
So it won't matter. The point is there is no need of returning something in this function. Still, since you are returning something, so you can return anything then, just to avoid compilation.
Hmm.
Got the point?
Yep. Yeah.
Okay. So any doubt in this function that I have written?
No.
Okay. So now your job is to do the reverse of this. Your job is to give an input as n.
Oh.
So right now what we did, if n is there, we have printed 1 to n. Now you need to do the reverse thing very quickly. If I will give you n, you need to print from n to 1. You can have a look at this function for your reference. So start from the same thing. First, define this, try to find out base case, and then do the induction step. Okay? So I hope कि both of you should be able to write the function for this.
Okay.
Obviously, I'm looking for a recursive function, not a iterative just.
Yeah, yeah.
So given n, you need to like print from n to 1. You can have a look at this function for reference. But the thing is, you should start building your hypothesis first, then try to find out the base case, and then induction. Okay, so I'll be back in 1 minute. So done. Hello.
Yeah.
Okay.
Uh,
Please share your code.
do you
If
want
you
to go
want to
on?
take some time, you can take, or if you have already done it, you can take.
I need yours or yours this time since. Yeah, I just need to like copy it to WhatsApp. One second. Um, do you mind like typing it while I say? It's only like 2 lines. It's just that I can't like send it because like it's on.
Yeah.
Okay. So I mean, the hypothesis first was to print from like and then n minus one all the way till one. Um, and then
Wait, wait,
n
wait.
minus one, n
The
minus
job is to print n minus
n
1.
minus one, n minus two, and then all the way till one.
Okay, this is
And
hypothesis.
then so I thought the base case was would be like if it's less than z. I mean, I thought it would be like if it's less than or equal to zero,
Hmm.
because even if so, because like if that's the base case, then it would just print like like it wouldn't do anything. That's what I thought.
Correct.
So you just like end the function there or something like
Correct.
that,
Correct.
and
Or like if
then
n is less than or equal to 0, yeah.
No,
yeah, and
I
then you would
mean
just
n. You can only write if n is 0. Why? Because if at n is equal to 0 you are returning, you won't be reaching n is equal to minus 1. Why? Because
oh yeah,
if you
that's
look
true.
very closely at each function call, you are just going one value down. So from 5 you will go
Yeah,
to 4, from 4 you will go to 3. So let's say from 1 you will go to 0 and you will stop here. There is no way you
yeah,
can reach minus 1. You can
yeah,
directly write if
yeah.
n is
That's
0,
correct.
just return.
Okay, and then it's just like the same thing that we did before. We just print out n, call the function print n minus one,
Wait,
like
and
function of n minus one.
so we will be printing function of n minus 1 and then
Yeah,
printing
and then
n.
you would
This is your induction.
no. So you don't print n.
We don't print n. Okay. We
No,
just
so you no. Wait, let me just say
right.
that. So you know the code that you've written down right now.
Hmm.
Hello.
Yeah, yeah.
Oh, you can hear me. Okay. So the code that you've written right now. So it's just that you would print n first. So just like switch like they don't have line numbers right now, but the part where you're saying C out, yeah, just do 13 over
Hmm.
12. Wait, let me see that again.
Yeah, yeah, good. That's what the
13 over
expected
12,
execution.
yeah.
So,
Yeah.
okay, wait. So,
Because
Arohi,
we're just doing it in reverse order. So, yeah.
okay. So, Arohi, do you think this function is correct now?
Um,
So basically, what Arini told me to do
one
is,
second.
I just swapped like these two lines. First,
Yeah.
the function was this. Okay, first the function was this. Now what I did was
Yeah.
I wrote this line number 14 above.
Yeah, that's what I did because once you print n, it's 5 and and then you start decreasing.
Because
So
at
yeah,
the
that's
beginning
what
it
I
would be n and
did.
then you just subtract 1, just keep going.
Yeah.
Let's see if it is working fine or not. So for
I
5 it
hope
should
it
so for 5 it should print 5 4 3 2 1,
for
right?
54321. It should, I mean,
It is.
oh, okay.
It is actually correct. तो अब तुम लोग ये सोचो कि लाइक तुम्हें अब समझ में आ रहा है लेट्स से कि अभी तुमने क्या किया है तुमने बस ये दोनों लाइन को स्वैप कर दिया राइट एंड इट वर्कड
Yeah.
so basically the point is कि whatever you define in hypothesis whatever you if your hypothesis is whatever you define if your induction is correct your function will work whatever you have defined in hypothesis it will follow that समझ आ रहा है
Mm,
बात तो तुम्हारा बस
yeah.
काम यह है कि
Huh.
hypothesis लिखना यार what should be the job of this function if you have written that
Huh.
then you should be able to divide the task into similar subproblem smaller subproblem you can say right now
Okay.
which is the induction step if you are able to do these two steps then go ahead and apply recursion because फिर तो तुम्हें पता है ना कि एक बेस केस तुम्हें फाइंड आउट करना है बेस केस तुम पहले लिखोगे उसके बाद तुम अपना इंडक्शन लिख दोगे दैट्स इट
Huh.
आ रही है ना धीरे धीरे फील थोड़ा बहुत समझ में
Yeah, yeah, I am.
ओके ग्रेट बार बार like हमें number set करना पड़ा है. Let me do this. Now I think like number will be by default. Yeah. Cool. So what is the time? Okay. What is the time right now there?
It's 2:30.
2:30 a.m.
Yeah.
Do you want to sleep?
We don't.
Hmm?
Sure.
No, no. If you want to, like, we can continue the session sometime. Like there is still
Arun, would
like
you?
some things to discuss, but like since it is 2:30, I'm not really sure to extend the session. When do you usually sleep? At what time?
Like around 1,
Around 1. So it's good. Like we should stop
1:30.
here right
Okay,
now,
sure.
so that we
Okay.
don't like so that you don't
Yeah.
like change your sleeping schedule, right? Because the sleeping
Yeah.
schedule and routine is very important.
Okay.
Cool. So now next in the continuation of this session, like we will be having recursion 1.1, which is like the continuation of this session only. So in that we will be also, so for now, like we have looked till here, print 1, 2 and into 1. Now you can also like solve some of the basic problems as well, which is like, you can solve a lot of iterative problems using recursion, right? Which is like checking whether a string is palindrome or not, sorting an array using recursion, very basic one. And then we will be discussing one more like very famous problem, which is Tower of Hanoi. So all these problems you can solve using induction based hypothesis method. So you got one method, you got to learn about one method using which you can solve recursion problems, okay?
Yeah.
Which is induction based
Yeah.
hypothesis. First you write hypothesis, which is defining the function. Then you try to find out the base cases, and then you do the induction step. Okay? Or the point is you can also change the order. First define the hypothesis. Okay, first step is this, defining the hypothesis. Second step should be induction, and then when you write induction, you'll get to know about base case automatically. Because if this is the induction step, you'll get to know ki, okay, fact should not be like, since we are calling one level down always, fact should not be like 0.
Mhm.
Because on 0 there is nothing defined. So you can also say that.
Yeah.
Okay, it's up to you. Like the point is कि hypothesis and induction is like main two things. अगर ये दोनों चीजें हो गई तो फिर base case तो तुम निकाल ही लोगे. ठीक
Makes
है?
sense. Mhm.
Cool. So when should we have the continuation of this session?
Same time
Same time tomorrow?
tomorrow. Yeah.
Cool. So I expect you to watch this recording before tomorrow's session
Yeah.
and practice everything we have implemented by yourself.
Okay. Yeah. Sounds good.
Oh.